Welcome back to the channel, guys. Today we're going to teach you how to do body work without body filler. No Bondo, no mud, whatever you guys use, we're not going to use it. We did the last video where we talked about hammer and dolly, shrink and stretch. Well, here is a very real life scenario that we're going to deal with today. It is dealing with a 49 Willys hood that has been severely damaged. All the inner structure on it had been removed at some point and then put back in. And they did a ton of brazing because I don't know if they didn't have a welder or what the scenario was, but it warped the hood so bad that when you guys look at this hood, I mean, we've sprayed the blue Dicam and we've blocked it so you can see your highs, your lows. And when we talk about assessing the panel, you have to think about what has happened to the panel and how are we going to reverse it. How are we going to reverse this one is if you have an oil can, most people where the hood is constantly pushing in and out, dong, dong, back and forth. Well, what people do is they'll take a sharp hammer and they will hit the hood to shrink the metal in and hold it and make that hood stiff. And then a lot of times they would just body work over it. Well, one, you don't want to do that because then your body filler is excessively thick. Like this is extremely low for what we're used to dealing with. And we want to take all of these hammer ping marks that are pushed in and stretched, and we want to shrink them back down. So we're going to be using a flat toe dolly and a hammer, body hammer, and we're going to work every single one of those back down and shrink them flat in with the hood. We're going to then flip the hood over. We're going to remove all the inner bracing, which we've already started doing. And then we're going to take all the brazing out of it. We have to have everything back to as close as we can. You can see there's a big hole. I don't know, maybe they had an antenna or something and it's pushed in. So we need to hammer and dolly that back up. We need to make a plug and then TIG weld that in. And so we can planish and get everything back as close as we can before we can actually start hammer and dollying and dialing it into a good finish. But this is gonna be very raw and it's a real life scenario, so it's gonna be really good. Just to reiterate, the hammers that we use are completely finished and just slightly rounded. The edges are not sharp. That way when you're hammering, you're not leaving a round impression in the hood. The other thing is we're using the toe dolly. These have all been sanded and corrected. There's no imperfections in them, and this side is dead flat. So we're gonna have to come in. Everywhere you see holes, tears, we have to get that sheet metal lined back up before we weld the tears and before we patch the holes. So that's what we're working on doing is we're shrinking, cold shrinking, hammer on dolly, cold shrinking until we hear the loud ping, pushing it into itself and tucking it. That way we can put it over by the welder, weld everything up, weld the patch in, and continue the process. When we're talking about hammer on versus hammer off dolly, when you're hammer on dolly, you're gonna have a very loud ping noise. And when you're hammer off dolly, so just here as an example, hammer off dolly has a very thud noise. And to be honest, when you're looking for your dolly, get a loud ting, you always want the loud ting. If you're even, like that dolly is this big, you can't just be over the dolly. None of these areas are actually going to have the loud ting, but one little tiny 1/8 inch area. And that's how you find your dolly exactly. And then you can move and pivot from that point. So we are going to very specifically, when you are cold shrinking, you're not going to hear the loud ting at first until you have taken that area that is stretched and shrunk it down. Once you hear the metal go from a thud to a loud ting, you have now shrunk the metal back down into itself. The second that you hear the loud ting, you're now doing something different. You are moving the metal, you are overstretching the metal, so you need to stop. Just so you guys know, we also have another video that we've recorded where we talk about shrink stretch, your hammers, your dollies, how they work, how metal moves, and how it shrinks. So if you guys haven't checked that out, check it out in the description. We'll put a link in there for you guys. When you are cold shrinking, in this instance that we're trying to do, we're trying to shrink all this stretched metal out that's already been affected by all the underneath here is where the brace is. And we had a bunch of brazing that was done, and there were holes apparently back when they brazed it. And I didn't realize that until we flipped the hood back over to the top. I'm sitting here trying to shrink this down, couldn't figure out why it wouldn't shrink. Well, when we flipped it to this side, you can see that there is bronze that has gone through a hole and or that they blew through when they welded it. And that thicker weld is not allowing me to get the panel back down flush and flat. So you have to remove any excess material. It could be undercoating, it could be a weld, it could be anything stuck on the panel that is not the clean sheet metal. It's going to hold that profile. As you hammer and dolly it, you're only smashing the weld, and it's, especially brazing, is not gonna smash, especially a piece that big, is not gonna smash as flat as the thin sheet metal is. So we're gonna grind this out, and then we'll be able to actually hammer and dolly that flat so we can weld the holes up. Another thing you don't want to do is you don't want to be wearing the area around it thinner. Then you're going to have even more cracks. So I'm purposely trying to stay on the brazing as much as possible. I'm using a 36 to get down the majority of the weld, and then I'll switch to an 80, and I will just very carefully, even if you have to use a carbide piece end mill on a die grinder just to get in there and work that little tiny weld out. It is a lot softer of a material. It's a lot easier to remove than an actual sheet metal weld. So. Anytime you're trying to grind something that's down in a cavity, like for example, this brazing that is down in there, we use the carbide to come in here and just work this down a little bit more. And maybe you can't get it all right now, but then you can hammer and dolly it with the toe dolly on the back side and start smashing the metal flat, and the stuff that's at the very bottom will then be easier to get to. It'll hammer it upward so you can come in and grind it a little bit more, hammer and dolly it, grind it a little bit more. It just keeps bringing it up flush with the surface. If you don't take out the weld little by little, you'll end up damaging the metal around it, wearing it thin, and then you're gonna have a bigger issue. If you guys look at this, that we've already removed the structure, and somebody at one point in its life had brazed it on. When they brazed it, they introduced a ton of heat, which also warped it. But I think there were also, I don't know if it was cancer holes or areas where the welds, when they removed it, looked like it had been torn out. So we have to start hammering down everything that's excessively stretched, right? So we're talking like in here where you have these very sharp points from where they took a sharp hammer and tried to shrink the metal down. We're going to be using the toe dolly underneath, and we're going to take the hammer over those highs, and we're going to push them down into themselves. This is where you're going to listen for, at first it's going to sound like a hammer off dolly until that gets shrunk down. Once it gets down, you're going to hear the dolly with the loud ping, and that's where you know when to stop. Ping, we have shrunk. You can already see that it has shrunk it down, and that's where we're going to move on to the next one. There's a whole bunch of these in a whole cluster of areas. The other thing is, if you're trying to hammer and dolly something, whether you're trying to stretch it or shrink it, and you have these areas that have spot welds that are left, you have to make sure you grind those down flush without removing sheet metal itself. Just remove the weld or the booger that's on there before you can metal finish anything. guys noticed, just by shrinking those tiny little tabs, it already oil canned in. And for those of you who don't know what oil canning is, this is it. You can see how the metal, it moves really freely, very light. The whole hood obviously doesn't have any structure yet, but just by shrinking these, we're taking huge loads that you guys saw in the very beginning photographs of this, and we're just taking them out. What you should know is anytime that something starts oil canning, you're close to getting it repaired at the relaxed state that it needs to be in. So we're just gonna take our time. We're gonna remove all these jagged pieces of sheet metal that were left over from all the brazing. And once all of the brazing is completely removed, we can then come back and we're gonna start fixing these holes. And in order to fix this hole, we're gonna take the tow dolly again. You can see the metal is shoved inward from maybe an antenna. We're gonna put it right below it, and we are going to shove the metal back down into itself, shrinking it. And just like that, you've shrunk the metal back down into itself. We now have it nice and flat. It's starting to take the shape that it originated from, and now we can make ourselves a perfect patch. Now, you could take a MIG welder and you could start to buzz this hole up, but you're going to introduce a ton of heat to it, and we're not going to recommend a MIG welder because it's a very hard weld. I don't necessarily disagree with using MIG welders. I think there's a time and a place for it, but when we're trying to do something on a very high-end vehicle like this, we are going to use a TIG welder because the welds are soft enough that we can hammer and dolly the finish, get everything smashed back down to the same plane, and when we're done, you will never know there was ever even a patch in that area. The TIG welder puts a lot less heat and it's way more workable. So MIG weld, if you were to MIG weld this up and then grind it smooth and try to do hammer and dolly work, the weld cracks out, and that is the problem. So figure out what your project may need. Maybe MIG welding is fine and you can just leave a little bit of the weld profile there, and it will be shrunk in from the heat already to where you could do your body work over it. For this thing, I want to make sure when they open this hood at the show that we have a perfect finish in metal underneath. I don't want to see a show quality finish on the top side and then you open the hood and you can see all the waviness on the inside. We want to make it just as good in sheet metal before we even move into body filler. This is going to be like a patch panel replacement on a very small scale. We hammered and dollied this stretched hole, so it actually came out quite a bit better. You don't want to try to patch this before you have hammered and dollied this back into the right shape and nice and flat. So we are going to plug 2 holes with 1. That sounds wrong. And then we're going to use a scribe. A scribe is basically a metal pencil. And this is how you're gonna get a perfect fit. Now, if you were doing a MIG welded patch, you wouldn't have to have such tight tolerances. But when you're doing anything with TIG, it doesn't like any kind of gap at all whatsoever. So we're gonna use this to scribe into the blue dicom, and it's gonna give a really perfect measurement on exactly where we gotta cut. Okay. The other thing we want to do is maybe put a mark on the piece and on the hood so you know what orientation you had it when you took it out. Now we can come in and we can cut this hole. It will drop right in. We'll use a magnet to hold it flush, and then we'll start tack welding it in. And even though this has a little bit of a shape to it, we're going to hammer and dolly and then planish that shape into the hood. So what we'll do is, when we talk about what happens when something gets welded, it welds, it gets hot, it rises, and then when it cools down, it shrinks just below where you started. So if we were doing this, and keep in mind, we want it where when the hood opens at the show, you don't know that we ever even put a patch here. So if you were to weld it, it will shrink down into the hood. We will then have to, have you ever tried to grind the welds and then you get to the point where you're almost completely smooth and you can't get to the very edge? That's because you need to hammer and dolly and stretch that back up. And then you can grind a little more. Same concept when we were doing that hole with the brazing, getting rid of it, you gotta hammer dolly, grind a little bit, hammer dolly, grind a little bit until it's completely smooth. And that's why we picked TIG welding, because we can put it back smooth. We know we have good penetration all the way around, and we don't have anything that's gonna crack out. These little air saws are super handy, other than disregard my tape that's holding the bottom screw in that's stripped out. But it works really good for doing sheet metal repairs, cutting. Just make sure you have safety glasses on, because these things will throw it right directly in your eye. All right, we have cut the hole. We've taken a small magnet to be able to set it in flush with the other panel. And part of the reason that you always want to make your patch panels have round edges instead of a square edge is if you are heating and shrinking two different planes, they kind of fight each other. The metal does not evenly distribute the heat. So going around a corner, especially with it's perfectly round, you're not going to have as much issue when you go back to stretch the metal back out. It's not binding with like a square plug that you're putting in. Even if you are going to put a square plug, round the edges of the square plug so that way it evenly distributes the heat as you weld it, and it doesn't warp the panel in one direction and the other direction fighting each other. So we're going to take this, we're going to use a stripper disc like we'd use to strip the car, so we're not removing any metal. We just want to remove the blue dicum from it. And when you're TIG welding, you want these gaps to be as close to perfection as you can. So we just rough cut it with the saw, and then we took a rat tail file and we sat there and dialed it in right to the scribe mark, so that way this thing fits in there perfectly and you don't have any gaps. If you did have a little gap, we'll show you once you get this cleaned up and we get a couple tack welds in there, how you can close up the gaps by just hammer and dollying the two different pieces of metal right where they meet, and it will actually smash the last little bit together, and then it makes it even easier to TIG weld it. Now that we have it tacked in, we're going to take the dolly on the rounded side, so that way we have a little bit of stretch, and we're going to place it underneath with the hammer placed over the seam between the two panels, and we're going to tap it till we find the dolly. And we have an area every single tack weld that has shrunk some, so we're just going to bring it all back in level before we move forward and TIG welding the whole thing up. The other thing it's going to do is smash any areas that do have a little bit of gaps in between the two. It's going to close it up. So we're gonna TIG weld this up right now. Something to take into consideration is when you're TIG welding sheet metal, you need to be using the same size filler rod, if not a little bit smaller than the sheet metal that you're actually going to weld. The other thing you want to take into consideration is that for every 100,000th of an inch, 1,000 per 1,000th is for every amp on your TIG welder. So this is approximately 43 amps. You should be somewhere in the ballpark of 43 thousandths of an inch thickness sheet metal. You need to be about 43. I usually set it a little bit higher than the 43 on the TIG welder, and that way you can melt the two together. Because if you had a thicker filler rod, it would take more heat to melt it into the two, and then you have more warpage. The whole goal here is you're getting in with the heat and you're getting out. You're not sitting there for a long period of time. You can see here the affected heat zone is very small, and that way you only have to hammer and dolly that area to bring that weld back up. So we're gonna go through and weld this thing continually around. As a rule of thumb, when you're welding any kind of metal, you do per thousandths of an inch to your amperage. Now, sheet metal is a little bit different. It's a different animal. So if you had, say you're doing a roll cage, that's pretty accurate for the amperage settings. And some guys like to weld hotter and some guys like to weld colder. But some of the things I've been learning myself is that when we TIG weld sheet metal, you want to do it a lot cooler. So even though this is around 43 to 45 thousandths of an inch on the sheet metal thickness, we ended up liking around 28 amps on the actual TIG welder, and it made a big difference on one side versus the other, just welding up this small hole. It keeps your warpage down, and when you look at it, you can see one side versus the other that one has a little bit less warpage and one has a little bit more warpage. Not that that's a big, huge deal, because we're gonna hammer and dolly it out and bring up that shrink that happened. At this point, we're gonna take our die grinder, we're gonna put a 36 grit wheel or an 80 grit wheel. 80 grit wheel is pretty good for TIG welding, 36 maybe if you're MIG welding. And you're just gonna take the top of the weld off, so that way it allows the dolly to be able to move the metal upward. If you have the high crown still on the weld and you're hammering and dollying it, it's thicker than what you're trying to move. So you need to try to slowly bring that up and hammer dolly. Bring it up a little more and grind. Bring it up a little more and grind each time until it is completely metal finished. Really try hard not to remove metal on either side of the sheet metal. You want to stay directly on the weld. Sometimes if you have excessive penetration through the bottom side of the weld and you're trying to take your dolly from the back side and push up to bring that low up, the weld that's hanging down is thicker than the sheet metal, and you have to sometimes, if you can get to it, flip it over and just kind of surface, getting rid of that slag that's come through the bottom of the weld before you can truly metal finish it all the way down. We've got the antenna hole welded up and we've metal finished it all up. So the weld that shrunk, we've brought back up and we've cleaned the weld up to where it's completely smooth. That solves that. However, where the inner structure used to be, it had been brazed on, and I mean excessively brazed on. So when we removed the brazing, and whoever had removed the bracing in its previous life, keep in mind this is 1949 hood, this is where the brace was underneath, and it had ripped the top of the sheet metal pretty bad, to where we attempted to TIG weld the cracks up, but the more that we introduced heat from the TIG welder to it, the more it showed how many cracks was truly there. So that really didn't work. So we took this piece out. We've drilled with a unibit 4 holes so we could make a nice round rectangular hole that we can put a patch in. But because somebody has used a pick hammer to take care of an oil canning problem that somebody had had at one time, if you look at this hood as a sheet, and let's just say you took a socket under the bottom with a pick hammer and you smashed the metal into the socket, you gathered that sheet into one area, pulling the metal tighter as a whole. That's what most people would do, or just using the pick hammer itself without a socket pulls the metal into itself, so that way it doesn't oil can. And keep in mind, when things are oil canning, it's not really far off from being nice and solid. But the fact that they have hundreds, literally hundreds of pick marks in the top of this hood, we came around with the hammer and dolly and we have shrunk them. Well, when you shrink a sharp point down, you're still left with a little bit of crown. It's that little bit of crown that you need to get shrunk all the way back down into the shape that it was that provides the oil can. So how do you get rid of the oil can? This is the number one thing you guys are gonna get out of all these videos, and this is a very quick demonstration. We have sprayed Dykem blue layout fluid over this whole area. What we're gonna do is we have to finish this area, get it all back perfect before we can put our patch in and weld it, because if those inconsistencies of the hood are there before we weld it, it's gonna be really hard to get a perfect patch put in there and everything on the same level. So what we did was we're taking an acrylic block with a sticky paper. In this case, it's 120. Doesn't really matter what grit you use. And we rubbed over the top. What that's showing you here is it's showing you the shiny high spots. Now here is how a shrinking disc works. This is Ken Sakamoto's stainless steel serrated shrinking disc. It needs to be mounted to a 6,000 RPM grinder, not a buffer that runs at 2,500. Ask me how I know that doesn't work. It doesn't give you enough shrink and it creates more problems than it does. You need to effectively shrink only the highs. So when we first started doing this, before taking a metal finishing class, I would take the shrinking disc and I would rub the area that I thought was low, thinking it was gonna shrink the low and pop up. It doesn't work that way. This thing is like the unicorn. There's a lot of people that don't believe in it. I am a firm believer in it after Ken's class. So we're gonna take this and we are going to hold it. You definitely want eye protection and you definitely want ear protection, but because I'm trying to show you guys, I'm gonna skip the ear protection. But you do not want the stud sticking below, so we put some sandpaper in here just to give it a backing to push the disc out smooth. We are going to try and hold this flat and parallel to the panel, and what you're going to hear is a very high-pitched screaming sound when it's hitting the high. What it's doing is it's effectively only shrinking the highs. The disc rides on the high and it heats it, and this is where it comes to finesse. Depending on how big the high is, you need to apply more heat or more pressure down, but you want to just graze over the top and do everything with that finesse, little by little, and then you are going to give it some 10-15 second count to dissipate the heat out, and then you're going to come through with a wet rag and you're going to just give it a quick wipe, and you're going to let it cool naturally, so that way it's heating evenly and it's cooling evenly. You want the heat of this to be hotter in the high, and as it dissipates out, it's lower heat. That way you are only shrinking the most at the high and it's evenly shrinking things down. So listen for the scream. What we're gonna do is we're gonna show a spot in close where it's shiny. We're going to shrink it, we're gonna cool it, and that's what's going to shrink it down. And then at that point, we're gonna take the block and swipe back over it and show you that the area that was high is no longer touching, and the shrinking disc is only going to touch in the area right next to it. So you slowly work down the area as it gets bigger and flatter until you get the finish you want. As you bring that down and you have other excessive lows, you can then hammer and dolly and stretch those areas that are low up. You're trying to get it back to square one. Here we go. Now you'll notice that what was super shiny now has the tinge of the heat. It's super hot right now, and you want to give this a good amount of time to dissipate the heat. It does not matter. Most people that heat shrink with a torch, they don't have any area that they're going to and pinpointing that has to be the area that is shrunk. They don't really know where they're starting. This, you're using the block showing the high to know exactly where to shrink. That's why this is so effective. Now, can you just walk away from it and let it cool naturally? Yeah, you do not have to even use a rag. The big thing is give it time to dissipate out evenly. It's going to heat and it's going to cool the same. What we're doing with this is you're stopping the shrink. So let it do it evenly. At this point, we can come in and give it a quick wipe. And when you start out, start slow. We are then going to take our block, and when you come in here, if we had an area that was high and nice and shiny, if you look right here, you can tell when you get up over it that the shiny is now scraping around the area that was high. The area that was nice and shiny is no longer hitting, it has shrunk. So this takes time. This is not something that's just immediately back to flat. You have to block, heat it, let it dissipate, shrink it, recheck it. And now you move around on only the highs to bring that down. You can effectively see how it is shiny around, and down where it was shiny is no longer even touching. That is how a shrinking disc works. We're gonna make this hood part one of this particular project. Now we have like 4 hoods that we have to fix, and every single one of them has a different issue, from hammered and dolly work to cracked welds. And each hood, one of them sandblasted, one of them we've done a lot of welding on. This one we're gonna have to do welding on. So please hit the like button, subscribe, so that way you guys get notifications on how to fix this stuff and actually work through these real problems that we're gonna have. So we're gonna have part 2 on this. That is a quick overview on how the shrinking disc works, a little bit of hammer and dolly work, and we're gonna show you the next steps that we take in welding this patch, bringing the patchwork back up and getting everything to a nice good mirror. Till next time, see you guys.